Engineering Mathematics Part 1, Inverse Trigonometric Ratios and Differential Calculus. Inverse Trigonometric Ratios and Differential Calculus. 4.1 Inverse Trigonometric Functions. What do you mean by inverse trigonometric functions? Definition of inverse trigonometric ratios. Relation between inverse trigonometric ratios. Simple problems. Next, 4.2 limits. What do you mean by limits? Definition of limits. Definition of limits. Problems using the following results. This is important formula for limits. Important formula of limits. First formula is limit x tends to a. Limit x tends to a. X raised to n minus a raised to a. X raised to n minus a raised to n. This is important formula. Limit x tends to a. X raised to n minus a raised to n upon x minus a. Answer is equal to n into a, n into a raised to n minus 1. Formula is limit x tends to a. Limit x tends to a. Formula is limit x tends to a. Limit x tends to a. X is a variable. A is a constant term. A is a constant term. Formula is limit x tends to a. X raised to n minus a raised to n. A raised to n. Whole thing is divided by x minus a. X minus a is equal to answer is n into n is a constant number, n into a raised to n minus 1. Power of a is decreased by 1. Formula is limit x tends to a is a constant number, x raised to n is also constant, minus a raised to n also 1, 2, 3 number, a is also 1, 2, 3, minus 1, 1, 2, 3 number, upon x minus a. Same term is in denominator, x and a is equal to n into a raised to n minus 1. This is the first formula. Next formula, limit theta tends to 0. Limit theta tends to 0. Sin theta upon theta is equal to 1. Limit theta tends to 0. Theta is tends to compulsory 0. Theta is tends to compulsory 0. Sin theta upon theta. Sin of angle theta. Same angle theta is in denominator is equal to answer is 1. If sin of angle is 2 theta is there, same denominator 2 theta is in denominator is equal to answer is 1. This is a formula of trigonometric. Limit theta tends to 0. Sin theta upon theta is equal to 1. Next formula, limit theta tends to 0. Tan theta upon theta is equal to 1. Both limit formula for trigonometric ratios for only sine and tan. For only sine and tan. Theta is here. Theta is compulsory tends to 0. And theta is compulsory in the radians. Theta compulsory in the radians, not in degrees. If theta is given in degrees, then convert in radians. Next, simple problems, differentiation, definition of differentiation, Definition is given. Definition. Differentiation of x raised to n sin x, cos x, tan x, cosec x, sec x, cot x, log x, e into x, u plus or minus v, u into v, uvw, u upon v. V is not equal to 0 for u upon v. Results only simple problems using the above results. 4.1 Inverse trigonometric functions. Inverse trigonometric functions. Definitions of inverse trigonometric functions. Definition. Definition is given. Definition of inverse trigonometric functions. A function which is the reverse process of a trigonometric function. A function which is the reverse process of trigonometric function is for the inverse trigonometric function. Here one example is given. Example, we know that sine of 30 degree 1 by 2. Exchange sine position. If your sine goes into 1 by 2, then it becomes sine inverse. Therefore, we can write as sine 30 degree, sine goes to value 1 by 2, sine inverse 1 by 2. Our answer becomes 30 degree. This is known as inverse trigonometric functions. The domain of trigonometric function, is the set angles, and range is the set of real numbers. For trigonometric functions, angle 30 degree is the domain, and 1 by 2 is the trigonometric function range. In case of inverse trigonometric function, domain is the set of real numbers. This is the domain for inverse trigonometric functions 1 by 2, and 30 degree is the range of set of angles. Inverse trigonometric function of sin x is denoted as sin inverse x. Similarly, cos inverse x, tan inverse x, sec inverse x, cot inverse x, and cosec inverse x are the inverse trigonometric functions of cos x, tan x, sec x, cot x, and cosec x respectively. Next. Cos 0 degrees 1. Cos 0 degrees 1. Cos 0 degree is 1. Cos inverse 1, value 1 is 0 angle. Tan 30 degrees 1 by root 3. Tan inverse of value 1 by root 3 is 30 degree. Cot 45 degrees 1. Cot inverse of 1 value is 45 degree angle. This is the formula for trigonometric ratios and trigonometric inverse functions. Next. Sec 30 degree. Sec 30 degrees 2 by root 3. Sec inverse 2 by root 3 is 30 degree. Cosec 90 degrees value 1. Cosec inverse value 1 is 90 degree. If x is equal to sine theta, then theta is equal to sine inverse x. Sine inverse x is an angle. There is a difference between sine inverse x and sine x raised to minus 1. There is a difference between sine inverse x and sine x raised to minus 1. Sine inverse x is the inverse trigonometric function of sine theta, whereas sine x raised to minus 1 is the reciprocal of sine x. This is an important concept. Sine x raised to minus 1 is the reciprocal of sine x. That is, sine x raised to minus 1 can be written as 1 by sine x. 1 by sine x is formula is cosec x. In this concept, we can learn about sine inverse x and sine x bracket raised to minus 1 are different. Next, what do you mean by principal value? This is an important concept, principal value concept. Principal value. Principal value concept. Principal value. Amongst all the values that numerically least value of the inverse trigonometric function is called principal value. What do you mean by principal value? Among all the values, the numerically least value of the inverse trigonometric function is called principal value. Examples, sine 30 degrees 1 by 2, sine 150 degrees also 1 by 2, sine 390 degrees also 1 by 2. Therefore, inverse, sine inverse of 1 by 2 is 30 degree, 150 degree, 390 degree, comma, dash. The least positive value. Least positive means minimum value is 30 degree. Least positive value is 30 degree, which is called the principal value of sine inverse of 1 by 2. In this problem, least positive value is 30 degree. Therefore, 30 degree is called the principal value of sine inverse of 1 by 2. Next, principal value means least value of inverse trigonometric function. Next, sine 60 degrees 1 by 2, cos 60 degrees 1 by 2, cos 300 degrees 1 by 2, cos minus 60 degrees 1 by 2, cos 420 degrees 1 by 2. Therefore, cos inverse 1 by 2 is equal to 60 degree, 300 degree, minus 60 degree, and 420 degree. In this, principal value of cos inverse 1 by 2 is 60 degree, because 60 degree is the least possible value. This is the concept of principal value. Next concept, function domain and range of principal value of theta. Function domain and range of principal value of theta. Sine inverse of x. Sine inverse of x. Domain is minus 1 less than equal to x less than equal to 1. Range of principal value of theta is in between minus pi by 2 and pi by 2. Cos inverse of x, domain is minus 1 to 1, and theta value is 0 to pi, that is 180 degree. Tan inverse of x, domain is minus infinity to infinity. Theta angle is in between minus pi by 2, pi by 2. Cot inverse x, domain is minus infinity to infinity. Theta is minus pi by 2 to pi by 2. Sec inverse x, domain is open bracket minus 1 comma 1 except 0. For theta, range is in between 0 to pi, but theta is not equal to pi by 2. Cosec inverse x minus 1 comma 1 except 0. Theta is in between minus pi by 2, pi by 2. Theta is not equal to 0. This is the concept related to inverse trigonometric functions, domain and range of principal value of theta. Next concept, properties. Properties are rules. First property 1, sin inverse of sin x is x. Sin inverse of sin x is x. Cos inverse of cos x is x. Both cos inverse and cos is same. Tan inverse of tan x is x. Cot inverse of cot x is x. Sec inverse of sec x is x. Cosec inverse of cosec x is x. Here, sin inverse and sin both are same. Therefore, our answer is x. That is angle. Next, proof. Proof of above properties. First proof, we can show that sin inverse of sin x is equal to x. How can we show that sin inverse of sin x is equal to x? Therefore, first assume sin x is equal to y. First assume sin x is equal to y. Take equation 1. Then transfer this sign here at y position. Therefore, x is equal to sin inverse y. Next, x is equal to sin inverse. Value of y is sin x. Value of y is sin x. Value of y is sin x. Put value of y sin x from equation 1. Therefore, x is equal to, result is proved. X is equal to sin x of sin x is equal to x. Similarly, other results can be proved. Property number 2. Property number 2. Sin of sin inverse x equal to x. Cos of cos inverse x equal to x. Tan of tan inverse x equal to x. Cot of cot inverse x equal to x. Sec of sec inverse x equal to x. Cosec of cosec inverse x equal to x. Proof of properties 2. Proof. Let cos inverse x equal to y. Equation number 1. This bracket is considered as y. Let cos inverse transfer to at the y position. Therefore, x is equal to cos y. X is equal to cos. Value of y is cos inverse x. At the place of y, put cos inverse x from equation 1. Cos of cos inverse x is x. Therefore, our result is proved. Similarly, other results can be proved. Thank you.